Okay, in the second part here, we're looking for the zeros, and the zeros are the x-intercepts of the function. That's what a zero is. The zero is actually the x-intercept, and they're found by applying the zero product property. That's why they're called zeros. And if we look at the zero product property, if this was our graph in factored form, we know that y is equal to these three factors multiplied together. And we know that we could actually go ahead and multiply those together and we would get a polynomial, but we're not going to do that right now. We're going to leave it in factored form. And we know that if we are actually on the x-axis here, we know we're moving up or down nothing. So that would be nothing would be 0, so our y value would be 0. And this is why we end up using the zero product property, because our equation's equal to 0. So now we can just set each of these individual factors here equal to 0, and we'll know what our x-intercept is. So x here would have to equal -1. If we take x plus 2, set it equal to 0, we get -2. And if we take this factor of x plus 3, set it equal to 0, we get, -3. So here are your x-intercepts. Okay. Now the nice thing about this is we could actually take this information and find out a lot about this particular problem. So let me first show you on the calculator what this graph would look like. So on here, I've already gone through and I've taken the x plus 1, x plus 2, x plus 3, and I've entered it into my y equals in the calculator. Okay. If I go ahead and hit graph, you will see graph looks like that. Now, it's a little hard to see what's happening here, so what I'm going to do is I'm going to use the zoom box feature. So hitting the zoom key, I'm going to go to option number 1, select number 1, the zoom box. And as I showed you yesterday, we're able to draw a box around the area of the graph that we want, which is this area here. We really would like this zoomed in. So I'll move this cursor to the upper left-hand corner of where I want to zoom into, hit enter, and then I can hit the right-hand arrow key on my calculator, and it'll stretch the box over to the right, and then I can hit the down arrow key to bring the box down. Now when I create this box, I'd like this box to include the y-axis so I can see the origin, so I can count from 0. Then if I hit enter, you will see that the graph now is a little easier to tell what's going on, and it looks like it went right through this point, and that point. That's just my cursor. Here, and here, there was points, okay? And that looks a lot like it was -3, -2, -1, which coincidentally, from my work here, the x-intercept should have been -1, -2, -3. So it looks a lot like that. So we can verify that if we go to our table of values and look at our table here, look at -3, -2, -1. Your y values are 0 for each of those. That's what we expected, because your x-intercept is where y equals 0. Okay. Now you may say, wow, big deal. But when you think about that, what if we went backwards? Recall here that those are the same factors that we started off here, x plus 1, x plus 2, x plus 3. And we multiplied all that out, and we got this polynomial. Well, what happens if this was the polynomial that I gave you, and you didn't know any of this information here? What if we started there? So let's look at that. On our calculator, had we just started with this polynomial, here, let me bring this there like this. Here's x to the third power plus 6x squared plus 11x plus 6, which is this equation that we had here. Now, we already know what this factors into. We know it factors into x plus 1, x plus 2, x plus 3. But let's say we didn't know that. If we just plug that polynomial in there and hit graph, this is what the graph would look like. And recall here, it's a little hard to see here, but if we zoom boxed in here on this one as well, okay, drew a box around here, zoomed in, okay, blew that up, there's -3, -2, and -1, which again we could verify quite quickly on our table of values. Oh, -3, -2, -1. So if you knew that, then that would mean, if you knew your x-intercepts, well, what factor would get you an x minus 3? Well, that would have to be an x plus 3. What factor would get you an x-intercept of -2? Well, that'd have to be an x plus 2. What would get you a -1? Well, that would have to be an x plus 1. So y equals x plus 3, x plus 2, x plus 1. Well, isn't that what we started up here? Look, it's factored. So you can actually take this polynomial here and switch it into factored form by just knowing your x-intercepts. And your calculator can tell you your x-intercepts. Okay? Great way, if you're stuck factoring, you can find the factors. Okay? I'm going to talk about the multiplicity of a factor in the next video.